Okay fellows, welcome to lecture 16 module 1 of the video series Introduction to Data Structures in C. So today we'll be looking at some basic programming concepts and trying to solve it in this lecture. Okay, let's get into the first program. So the objective here is to generate 20 random numbers in sets of say 5. Okay, and the random numbers generated should be in the range of 1 to 10. So basically I want you to generate 20 random numbers in the using a built-in function. Okay, so let's get started. So first I have 3 header files in the preprocessive directive. The first one is the standard stdio.h, and then I have the standard lib function and the time.h header file. Okay, so the standard stdlib header file basically gives me access to a function called as rand function, which helps me generate the random numbers, and the time.h header file basically gives me access to a function called as time. Okay, which helps me read the system time. Okay, so let's see how to use this. Okay, so in the main function I have a called the function called as srand. So srand stands for seed of the random number. So the seed of the random number is been initialized from the time of the system. Okay, so the time function out here is from the time.h header file. This functionality is written in the time.h header file, and a null pointer is been passed to it. And what basically the time function does, it gives me the system time, it returns the system time, and it also saves it in a pointer given as a parameter to this function. So I do not want to store anything into a pointer out there. So basically I am saying that I am passing null to it, so storing it in a null pointer. Okay, so something like that. Okay, so I am not storing anything, but the time function returns the system time, and that time serves as the seed point to generate the random number. So this line is not mandatory, but what actually happens when if you do not include this is every time you run, you get the same set of numbers, same set of 20 numbers every time that you run this piece of code. So this might sound a little bit odd because random numbers should be random truly. So every time you run it, you expect to some new set of values to pop in. But that doesn't happen because of the concept of this seed. So if the seed is not specified, by default the compiler takes the seed to be 0, and for a given particular seed the set of numbers that gets generated for every run are basically the same. Okay, they are the same. Okay, so if you take in instead of 20, if you generate 30 numbers, those 30 numbers are going to be random. But when you run the code once again, you get the same 30 values over and over. Okay, that is because initially at the initial run the seed is kept constant to 0 by default. Now you can change the seed value manually, saying that once you can put it as 2, another time you can put it as 3, and so on. But I want it to be automated. So what is the thing which is truly changing all the time? It's time itself. So that's why we use the time function, read the system time, which changes every time you run the code, and pass it as a seed to the srand function. So every time you run this, the seed basically changes, and as expected you get new set of random numbers. So that is what this line of code does. It doesn't generate the random numbers, it sets a seed which changes every time so that you get a new set of numbers. Okay, so having done that, I need to generate 20 random numbers. So you have guessed it right, I use a for loop. Okay, an unsigned int is taken as a counter out there. The initial value is 1, the exit value is less than or equal to 20, so 20 numbers get generated. And basically you can write I plus plus or plus plus I, doesn't make any difference because this is post increment, this is pre increment. So every time this gets executed, I becomes I is equal to I plus 1. So doesn't make any difference. So it gets incremented. That's the takeaway. So having done that, in the next line I basically generate the random numbers. Okay, and I want the numbers in the range of 1 to 10. So that's what this modulo operator does with respect to the rand function. Okay, suppose if you want numbers to be generated from 1 to say 50, you should have given, one needs to give it as modulo 50. Okay, so that's the format how it works. And the rand function basically generates numbers from zeros, but I want number from 1, so I add 1 to it. So it's as simple as that. Okay, so I add 1 to it because I need to generate numbers from 1 and I need it up to 10, so this 1 plus is for that and this modulo 10 is for this particular value, so up to 10 gets generated. Okay, then I check for, and what does this percentage d do? It basically prints it out, okay, by up to 6 decimal places. So if the number is 1, what it does is it reserves the 6 places, blank spaces, to print out this number, and by default the number gets left aligned, so the number gets printed out here. The next number, again 6 places are allotted, 3 6, and the number gets printed out there. Okay, so it's like, so reserve 6 places to print out the number and print the number as left aligned, so the output of this function gets printed out there. Okay, so here, so that's it. Okay, this is for that percentage 6 d. Okay, so that is what happens out here. Okay, and after printing out a set of 5 numbers, you want the next set to be printed on the next line. Okay, so I check whether I modulo 5 is equal to 0. If it is 0, then print it out on the next line. So you could use a put s, or you can use a printf /n. Okay, both are fine. Okay, so that's what the code does, and at the end of the program, this is the output that you get. Okay, you might be getting a different number because the seed will be different, but if you keep it as 0 or 1, then you see that what's actually happens, then the number that I get and you get will be the same. Okay, so, but out here for this piece of code, you will get random numbers, 20 random numbers for every run that you do. Okay, so let's go to the next piece of code. So what is done in this program? Here basically there is a task which is given to you. So given the basic salary, you need to calculate the gross income of an employee, and the rules for calculating the gross income is, if the basic salary is less than 10,000, then the HRA is 20% and DA is 80%, and the gross salary is DA basic plus DA plus HRA. So that is the gross salary of the employee. So if the basic salary is less than 10,000, then the HRA is 20, DA is 80. If the basic salary is between 10,001 to 20,000, then its DA is 90% and HRA is say 25%. And if it is more than 20,000, then the HRA is 30% and the DA is 95%. So based on this table, given the basic salary, the program should calculate the gross income. Okay, so you guessed it right. So based on this condition, you need to either execute this block or this block or this block. So which is the control statement that gives you this kind of leverage? Okay, mind you, it's not looping, it's not iterative. So given once, it has to basically calculate the salary, gross salary, and then that's the end of it. Okay, so it is the if else. Okay, so if the condition is true, do that, else if this condition is true, do that, else if these two are not true, then obviously he is into this category, so do that. So obviously it is the if else which comes to our rescue in order to accomplish this task. So let's get to the code. So first, in the main code, I have variables defined to store the basic, to store the gross, the DA, and the HRA, which are the intermediate values which are being calculated. Okay, so DA plus HRA plus basic will give me the gross. Okay, so in the next line, I ask the user for the basic salary of the employee, read it from the standard input and store it into the variable which is being defined out here to store the basic, which is a float. Okay, so having done that, then based on the basic, calculate the DA and HRA and calculate the gross. Okay, so as I told earlier, check for the first condition. If basic is less than 10,000, less than or equal to 10,000, then DA is this much, 0.8, HRA is basic into 0.2, else if it is less than 20,000, okay, so it will be obviously greater than 10,000 because this is already checked once and it is not true, but it is lesser than 20,000. Okay, you could have well checked for the scenario, something like that. Okay, so that becomes what we say, obvious. Okay, that is inherent. So because you already done this check. Okay, so you check for whether the basic salary is greater than 20,000, okay, or lesser or equal to 20,000. Obviously it will be less than 10,000, more than 10,000, since this was not executed and you are out here. So it will be more than 10,000, which is inherent, and it is less than or equal to 20,000. So you are in this condition right there. So based on this condition, I calculate my DA, which is nothing but basic into 0.9, that is 90%, and HRA is basic into 0.25 because HRA is 25% of the basic. Okay, else if these two conditions are not true, then I move into the next condition and calculate the HRA and DA appropriately. And after all this piece of code is done, all these conditions are executed up to here. Okay, based on the values of what DA, HRA and basic are, I calculate my gross, which is outside the control loop. Okay, so this is where the control loop ends. Okay, so then I calculate my gross based on the basic and HRA and DA that I have calculated in any one of these three blocks of code. Okay, and having calculated the gross, I print out the gross salary of the employee. So hope it's clear. Okay, so let's go to the next piece of code. So here I want you to generate a random pattern which is like this. In fact, not a random pattern, a number pattern. Okay, I want you to generate a triangular number pattern like that. So 1, then I want 1 2, 1 2 3, 1 2 3 4. So I want you to write a C code to generate this. Okay, the logic is that I have two iterations going on. One variable which goes from here to here, that is for the row scan, and then I have one for the column scan. Okay, one is for the row, the other one is for the column. Okay, so the row basically goes from so if you want 4 numbers out here, so the input should be 4. So row basically goes from 1 to 4 and column goes from what to what, from 1 to row, right? So when the row is 1, the column is 1, only one number gets printed out. When the row is 2, column goes from 1 to 2. When the row is 3, column goes from 1 to 3. When the row is 4, the column goes from 1 to 4. Okay, so if you have guessed that I need 2 for loops, then you have got it right. Okay, the first for loop goes from 1 to the row value, and the second for loop, as I said, goes from 1 to the row value for I goes from, let me just rewrite that again. So for the first for loop, I goes from 1 to row, and the second for loop, say j, goes from 1 to the current value of the row variable, that is 1 to I. So that was the logic of this code. So now let's start implementing it. Okay, so this is the piece of code which implements it. So as you know, I need a variable to store the user input, what should be the number of rows that I want to print out, and then I have two counter variables, one I and one j. Okay, so read the row value from the user from the standard input, store it in that particular variable name. Okay, and then I have the two for loops out here. So the row goes from 1 to rows. So if the user has given it as 4, it goes from 1 to 4 I plus plus. And the second loop, which is inside the first loop, goes from 1 to I j plus plus. Okay, so when row is 1, column goes from 1 to 1. When row is 2 or when I is 2, column goes from 1 to 2. When I is 3, j goes from 1 to 3, and so on. Okay, and then I print the value of j. Okay, and for every iteration I need to go to the next line. So basically, after iterating through this loop, mind you, this is the body of the innermost loop, I print out a next line. So after each column is been printed out, I go to the next line using this particular command, print \n. Okay, so that is what happens with this piece of code. Okay, so here is another program. Instead of numbers, I need to print asterisks. So what is the change that I need to do in this code snippet, so that I can change the pattern from a number pattern to an asterisk pattern? Basically the pattern is the same. Okay, so if you have guessed that it is just one line that I need to change, and that is this line. So instead of printing the value of j, now I need to print a character asterisk. So that is the line that basically changes, and the rest of the code exactly remains the same. There is no change in the other part of the code. So that is how you generate a number pattern and a star pattern as given out here. Okay then, so let's go to the next problem. So here I want you to basically find out, what is asked for you is whether a given number is a Armstrong number. Now what is an Armstrong number? Suppose the number given to you is say 153. So you need to split them into individual digits and take the cube of each digit, add up these cubes or accumulate their values. If the accumulated values is equal to the same number, then we say that the given number is an Armstrong number. Say for example, here the number given is 153, so I first need to split it out as 1, 5 and 3, then take the cube of 1, which is 1, the cube of 5, which is 125, and the cube of 3, which is 27. So having calculated the cube values, add all of them together, which gives me 153, which is same as this number. Okay, so I say that the given number is an Armstrong number. If it is not equal to, then I say that the given number is not an Armstrong number. Okay, so that's the logic. So now let's see how to implement it. Okay, so in the main code, basically I have variables to store this number, a variable to store the residues once I start splitting up these numbers. Having split out the residue, calculate its cube and then accumulate it into save it temporarily and then accumulate it into a variable which is called as sum, and initially the value of sum is 0, because that's need to be done, or else you will be having problems, because sum by default will have some junk values, so better initialize it to 0. Okay, So having all the variables defined, so I ask the user for the number, read the number. Okay, then I go through the looping. So I need to basically do the same process 3 times. So I say temp is equal to number, so that is the initial condition, okay, where num is the counter itself. The num value will serve as a counter itself. So initially I store this number into a temporary variable temp, and I use num to basically start changing the values of num and then find out whether the given number is a Armstrong number by comparing it to the temp variable. Okay, so initially the value of the counter is num. Till where should I repeat? Till num becomes 0, till I exhaust all the digits in the number. So till num not equal to 0. So that will be my exit condition. And how do I increment my number? I start depleting each value at a time. So num is equal to num divided by 10. So after each iteration, the value of num will get depleted by 1, the leftmost part, because num is an integer. Okay, and I am doing a integer division. So remember, in my lecture of arithmetic operators, I talked about integer division. So num is an integer, 10 is an integer, so output, even though if it is a float, it will get typecasted to an integer which is stored in num back again. Okay, so that's it. So then I calculate the residue by using the modulo operator. Remember the modulo operator that we had discussed. Okay, so in the initial run, num will be the same as num 153. Then I use my modulo operator to remove 3 out of it, okay, which gets stored in R, and then I increment the value of sum by adding it to the cube root of R. So sum is equal to sum plus R cube. Okay, so at the end of this, 3 will be out. Okay, num value will be 153 and the sum value will be 27. So after first iteration, num is equal to num by 10. So in the next iteration, the value of num will be just 15. Okay, so in the next iteration, again the same process is repeated till the last value gets exhausted out of num. Okay, that is when num becomes equal to 0, and that is the exit condition. So during that part, the sum value would be 27 plus this would have got exhausted and this etc. would have got. So having done that, we come to the next line of code and outside the for loop. Okay, and then we check whether the calculated sum is equivalent to the temp value which was assigned to the num value. Okay, because now is num is basically 0, that's why I came out of this loop. Okay, so I see whether the sum calculated is equivalent to the temp which holds this value. Okay, and if they are the same, then I print out a message saying that the given number is an Armstrong number, else I print out a message saying that the given number is not Armstrong number. Okay, so hope you have got this logic. Okay, and let's look into another piece of code. Here I want to calculate whether a given number is a strong number or not. Now what's a strong number? It's the same logic, but instead of taking a cube, I need to calculate the factorial of a number. Now if I calculate the factorial of each digit and then accumulate them or sum them up, and if the number is same as that of the given number, then I say the given number is a strong number. So in Armstrong number, I basically took the cube root of each of them. Here I calculate the factorial. The rest of the logic basically remains the same. Okay, so how do I do that? Obviously calculating the factorial requires a little more effort than just calculating the cube. For the cube, you just need to multiply that number 3 times, right? You have multiplied R 3 times in order to calculate the cube. But the difference out here is only this cube function will be replaced by a function that needs to calculate the factorial. Okay, so let's see how we can do that. Okay, so here is the piece of code Okay, so first I have the same thing out here, then I have the factorial which I call it as a long int. Okay, so there sum was there. Now I have something called as another variable called as factorial, because I need to calculate the factorial. As I said in the earlier video, I need not store the cube because basically it can be calculated with one single command, r into r into r. Whereas here I need to actually calculate it and store it in some value and then use it in this place. So that's why our long int fact is been defined. So the rest of the variables are the same. Then I read the number in the value n, then I assign it to a new number n1, and then I do the same thing. Okay, but out here instead of having r cube, I first need to calculate the factorial. Okay, I say fact is equal to 1 for I is equal to 1 to j modulus 10 and plus plus plus, then I say fact is equal to fact into 1. Okay, so that is how a factorial is been calculated. So what is factorial? Factorial is how do you calculate factorial? Okay, so factorial is calculated as, say, factorial of 3 is 1 into 2 into 3, so that's the factorial of 3. Okay, so that's how factorial gets calculated. So in the initial value I have for j is equal to I is equal to 1, and what is the value of j? The value of j would be, say, 5. So for I is equal to 1 to I less than or equal to 5, because modulo j modulo 10 will be 5, I plus plus, so I will go from 1 to 5, and every time factorial will get calculated as 1 into, it might be in the second iteration, 2 into 3 into 4 into 5. Okay, so that is what this loop does. Okay, so that is how factorial is been calculated in these 3 lines inside the for loop. Okay, so that is how factorial gets calculated out here. Okay, so in the earlier piece of code, this was just r into r into r for the cube root, but now I need to do a little bit more in order to calculate the factorial. So once the factorial is been calculated, it is been added to the sum here, which I call it as s1, and I say s1 is equal to s plus fact. So every time this loop squeezes out one number out of the given digits, okay, or one digit out of the given number, and this loop basically calculates the factorial of that particular digit. Okay, so that is what happens. Okay, and at the end of this you get the accumulated value of the factorials of individual digits. Okay, and then I calculate whether, then I check whether the given sum is equivalent to the number which is been stored in this temp variable out here. Okay, so if the factorial which is calculated out here, s1, accumulated value of factorial, that is sum of factorials which is there in s1, is it same as that of the number? If the number, if both of them are same, then I print out the given number out here is a strong number. If not, then I print out the given number is not a strong number. Okay, so hope that you have followed this lecture. Okay, the only catch out here was how do I calculate this factorial. Okay, so go through this. If you have any queries, refer to the handbook that I have given you along with this video lectures. Okay, and that should clarify it. If you still have any queries, you can post it in the given link of the YouTube channel. Fine. Okay, so that was all about it. Okay then. Okay, so hope you have enjoyed this video series. Stay tuned with me for the next lecture in this course. Thank you.